So this is going to be a tour of Django's nasal passage, a journey from its stock test equipment over to a wondrous boilerplate-free world where you can enjoy ponies and things like that. So first, welcome to Vodafone Secret Lair. We're trying to here reduce the influence of politics, or excuse me, Freudian slip, reduce the influence of money in politics by replacing like expensive broadcast media like TV and billboards and things with more efficient peer-to-peer interactions where people aren't as annoyed by their phone ringing from robots all the time. We do some fairly thorough applications of Django here and some pretty heavyweight testing. We have about 1,700 tests right now. And we've found the stock Django test framework, well, really easy to get started with, is not enough once your program scales beyond trivial. Here are a couple things that are wrong with it. So almost immediately, you get far too many tests to fit in that one little test.py module. So of course you turn it into a package, right? You blow it up, you split it out into little things, but then you have to import all the names from those little things up into init.py. And that's not only annoying, but error-prone, as we'll see. Things also end up slower than they could be. You end up having to do a full database flush for every transaction test case you have, and a full fixture reload for each test that uses fixtures. Also, the test runner creates an entirely new database for each time you invoke it. Each time you go back and rerun the tests, new database, very expensive. Third, the default test runner is kind of overzealous. Not only does it test your code, but it tests everything else that happens to be in installed apps. And that's going to be a lot of third-party stuff that's already proven to work. So at best, you're testing whether you have the third-party stuff configured right. And at worst, you're just wasting your time running tests on things that are already known good. Let's see here, UI. I find the default testing UI to be pretty rough. You don't get any tracebacks until everything is done in true text test runner fashion. And there's a lot of trash in the output, a lot of 80 equal signs here, 80 equal signs there, what's a line skip between friends. There are no facilities also for round-tripping back into the code. So when something goes wrong, you've got to eyeball that line number out of there and dig around in the file system and bring your editor up and all that stuff. You know, computers should be good at that. And then finally, the extensibility story is kind of unscalable. If you make, say, a Django test runner subclass that does XML output, and you can't just mix in somebody else's that does, say limits you to testing just the applications that are yours. Not easy to compose those. So Nose is going to help us solve all of those things. It's a really nice test framework. It draws on the unit test heritage, and then it puts it on steroids. It questions a lot of the limitations that come out of the strict, static kind of JUnit descended test frameworks, and it gives you the tools to test more stuff in fewer lines. I love it. So let's talk about Nose and how you apply it to Django. Before we dig too deep into its capabilities, here's how you install it. You just pip install Django Nose, which is a shim that implements a Django test runner, and then just calls out to Nose and invokes that from there. Nose itself is a requirement of Django Nose, so that just gets pulled down automatically. You don't have to install that explicitly. And then all that's left to do is set up your settings. Just add Django Nose to your installed apps, and set the test runner to Django Nose's fancy little test runner. Now let's see what that gets us. First of all, we have discovery. So Django's stock test runner, as we said, makes you pull everything into tests.init or tests.py. Nose, on the other hand, makes all of this go poof. Instead, Nose finds your tests by name. So these are some test-like names. If Nose finds a class or a function with a test-like name inside a module with a test-like name, it considers that to be a test. And if you have something that doesn't fit that pattern, you can always use a decorator. No, this isn't a test. Yes, this really is a test. Of course, subclasses of unit test.test case are always considered tests, so all of your old Django tests continue to be found, recognized, and run. So the application of these simple rules kills off a whole bunch of boilerplate, eliminates several classes of errors. For example, since we don't have to import into init anymore, you don't have to worry about things getting shadowed. We've had this happen a couple of times to us. We end up with something called such and such test case in one test module and something else called such and such test case in another module next to it. You do some pretty naive import stars into init, one of them wins, one of them doesn't run. Not a lot of fun. You get no errors, nothing to track down. It's just 6 months later you realize, this test hasn't been running ever since it was written. The other fun thing about not having to import up into init is you can reverse the typical import direction. You can use init, well, first of all, you can leave it blank. Or what I like to do is I put my base test classes in there, or little standalone testing utilities that are application specific. And then you can import down from that into your test modules without having to worry about circular imports or anything. You don't end up forgetting to import things. That's happened to us a couple of times. And then finally, you don't have these long, Java-like, crazy long names in order to maintain uniqueness. So all good stuff. And then remember how the test runner ran through all the installed apps? Well, Django Nose doesn't do that. It only looks in the folders within your actual project. So it tests only your code, saving you a lot of compute cycles, really. You save a bunch of time every time you test. This also means that you can have code in your Django project that's tested but doesn't live in a Django app. So you can have root level stuff in there, still is tested. So with all that freedom, how should you organize your tests? Here's my favorite way. I still like to nestle my tests inside a tests package in each app. Why not? Why change things that work? The init is either blank or, like I said, full of base classes. And then tests go in test whatever files, test models, test views, test robbers. That naming convention is nice for making the tests all kind of clumped together in contrast with other artifacts that you might have sitting in there, maybe an image file for testing some pill stuff, a sample data file. Another perfectly reasonable convention is to put the high entropy words first, model tests, view tests, and Nose is happy to recognize those as well. And those are a little bit easier to do type to select, a little shorter to do tab completion on. At Vodazone, we also toyed with splitting tests into a deeper hierarchy, tests and then put a models folder inside there and have a file per model that you're testing. And that is a matter of personal preference, but we found that that made us dink around too much in the file system, and we were willing to take some longer test modules as a trade-off. Another cool thing that Nose lets you do is break out of the test class pattern when it makes sense. You can just have flat-out functions as tests. So if you have something that, for example, doesn't require the typical Django database, rollback and setup teardown kind of things, you can just make a function. Perfectly happy test. And then Django gives you these little helper procedures like EQ underscore to replace things like self-assert equals. Nevertheless, there are allowances for setup and teardown. So you can see the decorator here, and that just takes two parameters, the setup function, the teardown function, and you can put the setup and teardown functions out at the root level or in a library, and you can mix and match. Something I'd like to do in the future with Django Nose is provide Django database setup and teardown as standalone procedures like that so that you could use them in top-level functions if you felt the need. To support function tests further, there are package, module, as well as a class and test level setup and teardown. So if you put a setup procedure at the top of your, say, init in a package, that'll happen before any test in the package is run. Similarly, if you put a teardown in there, that gets run after all the tests in that package get run. If you want to get really crazy, you can generate your tests dynamically. Now this is kind of a niche thing, admittedly, but sometimes it feels nice to generate several similar assertions programmatically, like in a for loop. In unit test, say you had a bunch of asserts in a for loop. When that first one fails, that whole test is shot. Now you have to go correct some things, and you don't get any more information about the assertions that didn't get run until you rerun the thing. In Nose, if you use a test generator, you can keep on going. So you can make a bunch of independent assertions, and you get all your feedback right at the top. You can't use this in unit test case subclasses, but it works everywhere else. Now here's a fun trick you can do with attributes. You can use this adder decorator that Nose provides to stick arbitrary tags onto your tests. It works on classes, it works on functions, and they can be unvalued like the top one or valued like the bottom one. And then when you invoke Nose, which you do through the typical managed by test, you can say, I want you to only run my Selenium tests. That is, the tests where an attribute called Selenium exists. Or you can do kind of Boolean expressions. You can say, give me the ones that are priority equals 2 and speed equals slow. Or you can do alternation. You can say, give me the ones that are priority 2 or with a slow speed. Really, really handy stuff. I can't wait to take more advantage of it. Lots of other goodies. I mean, we could go all day about Nose, but it has, say, custom error classes. So the typical unit test stuff, you've got errors and you've got failures, right? What if there are other kinds of useful things? Like you could yield a deprecation, for example, and say, well, yeah, it's passing, but it sucks. Skips, I think Nose either originated those or certainly had them before unit test 2 came out. To-dos, you could see something yielding a to-do, like, yeah, you know, this test is here, but it's not really doing what I want. XML output, you get that for free. So if you want to use Jenkins or something, you just pass it, I think it's --with-XML. That's what we're using to integrate with cruise control in our case. Lots of extensibility. All these things I've been showing, the discovery and the attribute thing, those are implemented as plugins. So you can customize all that stuff. And the plugins all get along with each other really nicely. They compose well. You get the plugins. Obviously, there's a good ecosystem of plugins going on. And there's even some multiprocessor support, though I haven't got it working with Django yet due to contention for a database, but that's a good future thing to look at. I hope to get more into some of this in my DjangoCon talk next week. This is a preview. So let's talk a little bit about some of the specific optimizations that Django Nose provides. Earlier when I said it was just a shim, I told a little fib. It sure started out that way, but by now it's got all these crazy performance-enhancing features that you can optionally take advantage of. So to demonstrate those, I'm going to use the example of support.mozilla.org, affectionately nicknamed Sumo, which I used to work on. Now, it's got about 1,200 tests. Gets about 1 billion hits a month. It's kind of a moderate-sized site for Mozilla. And over time, those tests have grown to take about 20 minutes on the build server and 5 minutes locally. Now, 5 minutes might not sound like long. It's easy enough to say, but it's worth saying a few words about why faster tests are desirable. First and foremost, you save all the sword fighting time while the tests run. It saved injuries this way, saved chairs. More importantly, you recoup the time you would have lost in context switching, reestablishing your flow, getting stuff back into your head. Third, when people know it's going to take 7 to 8, no, I think that's up to 7 minutes right now, really to optimize, they skip running pieces of them. They say, well, I was just working in this app, I'll just run this app's tests, right? So you run some of the tests or none of the tests, and then of course you break the build because you didn't run all the tests. So lots of good reasons to optimize here. So where does Django Nose go looking for that extra speed? Well, there's generally only one real answer for that, and that is I/O. If you take a look at this little chart, it represents 1 nanosecond of access time as a single pixel. Now, just take a look at how all the levels of memory hierarchy combined are just dwarfed by that mechanical hard drive. It's horrendous. So if you can take a chunk out of that, that's where to go first. Now, I'm lucky enough to have an SSD in this box, and things are a lot faster. Theoretically, an SSD has an access time on the order of 100 nanoseconds, so it's a little bit more than core RAM. But in fact, you end up bottlenecking on write. Reads are cheap, but writes, they're amplified, or they're just flat out honestly slow. So a little less true than it was 5 years ago, still the case. If you have a Mac, I recommend getting a copy of iStat menus or menu meters, similar things for other platforms. I mean, Linux has tons of them out of the box. Really great for establishing a baseline expectation of what a reasonable test load is. Python is terrible at multiprocessor use in general, and certainly is single-threaded for Django tests. So If you see Python not hitting 100%, that probably means you can optimize a little bit more. Our current tests run at about 70-something%. We could do better. We're better than we were. I think we started at 30. Let's see here. So we can confirm our I/O rule of thumb by applying a couple of profiling tools. First of all, obviously the Python profiler. But unobviously, it doesn't tell you anything about I/O time at all. It just tells you, oh, I spent 4 seconds on the CPU. Well, great, but my test took 1.5 minutes to run. Where's the rest of the time? So we bust out the handy Unix time command, which is nice. It gives you not only the CPU time, but the clock time and handy little ratios. You don't have to do any math. You can take a look at the CPU percentage, see it's using 30%, and you can conclude that whatever I was doing in my tests, a lot of it is spent in cycles outside my process. Either it's waiting on I/O or I've fired off some other process that's doing some computation for me. So a little bit more digging in the case of almost any Django project shows that to be database I/O, which is why Django Nose provides 4 optimizations for reducing it. The first of which is fast fixture test cases. So test fixtures. Hands up if you've used test fixtures, familiar with test fixtures. Yeah. Love them, hate them. Okay, evenly divided. A lot of no opinions there. So test fixture data typically goes into a JSON file, kind of like this one. This is an actual test fixture from the forum application in Sumo. And this one's on the small side, about 39 objects. Trouble is, you got to blow a SQL statement to make each of these objects. So that's 39 SQL inserts. Even in Django 1.4, you can't use bulk inserts for this because of the possibility of post-save hooks existing and wanting to insert additional objects or do important things. So you still need a SQL statement for each one. And here's one of Sumo's test classes that uses that fixture along with 2 other similarly sized ones, so a couple dozen inserts. And it took 4 minutes to run. It was not computationally intense. So what's going on? It seems like an awfully long time to load a couple of dozen database rows. Well, if you want to find out what's going on, in the case of MySQL, for example, you just log in as root and say set general global, type that. Then it'll start tailing every statement it receives to a file. You can take a look at that, and it becomes clear that not only is the fixture reloaded once per class, but in fact, it's reloaded once for each test. So 39 times number of fixtures times 20 tests in here starts to add up to 4 minutes. Each test begins a transaction, loads the fixtures, runs its stuff, and then rolls back the transaction back to a blank database. It's very tidy, but very inefficient. So, run, roll back, load it, roll back, load it, roll back. So on Sumo, this was 37,583 queries over the course of the entire suite. And it seemed to me that we could do a lot better. So here is a conceptual illustration of fast fixture test case, which exists. You can use it for free in Django Nose. We've got setup class. So this is a class level setup thing. It happens before any of the stuff runs in this class. Unit test 2 brings that. Nose has had that for a while. It loads up the fixtures. It commits them. That's the difference. So then when we run our tests, we run the test and we roll back, which takes us not to a blank database, but back to a pristine set of fixtures. And then finally, when we're done, we tear down the class by removing the fixtures explicitly, truncating tables, taking rows out, whatever, and then committing. Now, how do we know what to rip out? Well, we have a modified version of Django's stock fixture loading routine. We run that through a dry run. It records what it was going to do, and then we know what to rip out. So let's see how we did. With the stock Django fixture loading, Sumo fired off 37,583 queries. With the per class fixtures, only 4,100. That's 9 times less database traffic. Or if you look at it in terms of time, the stock fixtures are just over 5 minutes, and the per class fixtures come in at about 1.5 minutes. So you can get these improvements yourself. you just have to subclass the fast fixture test case instead of test case. Oh, and there's one little caveat there that if you have post-save handlers, you can't do that. But that's something that could be solved in welcome patches. In fact, there was an additional 4 seconds saved here by reusing a single database connection in Django knows. Django tends to flap the connection open and closed a lot, to be very, very conservative. So we went ahead and put the branch in to say, well, in this database it's safe, in this database it's not. And we saved 4 seconds, takes us down to 93 seconds. So big improvement, and all thanks to getting rid of I/O. But there are additional speed optimizations that we can apply. There is fixture bundling, which is kind of exotic. These are 3 actual test cases from Sumo. They use the same fixtures, as you can see. Now, if you wanted to optimize this, you could merge them all into one class, right? So they're only loaded at the top of the one class and then unloaded again just once. But then you can't organize your test classes as you want. It's nice to conceptually group these things sometimes. So what do? Well, we take advantage of one of Nose's little hooks. Nose has this prepare test hook, which is kind of misnamed. What it really should be called is prepare suite. So at the very beginning, before any tests are run, it says, all right, prepare test, you've implemented this, here's the suite, do what you want. And we decided to do some evil things. So here's how it typically happens. When Nose runs your test cases, it runs them in basically alphabetical order like this. So, test case 1, right? Loads fixtures A, B, and C, tears them down. Test case 2, loads A, B, C, and D, tears them down. Test case 3, loads A, B, and C, again, redundantly, and tears them down. Let's save that work. So by using prepared test, we can write a plugin to dynamically reorder these tests so that we don't repeat any work. So how does this work? Well, we load it there, obviously. We load the next fixtures there, and the next fixtures there. But how do they know what to do? We put advisory bits on the first test case of each group and the last test case of each group. And then, in a decoupled way, we have our fast fixture test case says, am I the first test case in the group? Well, if so, I better set up the fixtures. Am I the last test case? Well, if so, I better tear them down. Otherwise, I don't have to do anything. I can just cruise on, do my tests, and I don't have to worry about doing any I/O, and I save all that time. Throughout all this, test independence is fully preserved. We're just factoring out pointlessly repeated setup. Now, a future optimization you could easily see here is to be smart about subsets, right? We've set up A, B, and C. We could leave them there and then just bring in D. Now, I'm sure that's computationally intense, but as we saw from the memory hierarchy diagram, computation is all free. You can do as much computation as you want to avoid hitting the disk. If you have any trouble with this, you probably have order dependencies in your tests. So take a look at things like singletons. Locale is a big thing if you're activating or deactivating any locales in your tests. Those are thread locals and tend to leak, especially if you have an exception or something. And then any other thread locals are a great place for state to hide out. So what impact did fixture bundling have on our test project here? Well, before bundling, we had 114 test classes with fixtures, and we did the loading and unloading 114 times. However, it turns out there were only 11 distinct sets of fixtures, so with bundling, we can save about a quarter of the time off of our already improved test run. All you have to do to take advantage of fixture bundling is subclass fast fixture test case, say that 5 times fast, and then pass the with fixture bundling flag when you invoke your test runner. So another place that I shaved some time off is database reuse. Waiting for database setup is no fun at all, especially when you're just running a trivial test that adds 2 numbers or does a little computation or something. I think our current project takes like 15 seconds or something to set up our 3 different databases. And if you run on Amazon, you can just go to get some lunch, because that's going to take 10 minutes to set up. It's insane. So what I realized is at the end of your test run, your database is in a valid state. So why would I redo all that work at the front of the next one? Why not just leave it alone at the end of the last one? Why, don't tear it down, and then just reuse it as is. So we did that. The flag is not, the switch isn't very observant, I'll say. You have to keep track if you make any schema changes, for example. You have to omit the flag next time you run it and say, look, you better go ahead and reinitialize. But otherwise, you save, a good 10 seconds of database setup time. And there's the flag. It's a strange invocation because of the way the test runners call each other. I couldn't make it an argument yet, so it's kind of an environment variable. You just kind of do that. But research continues. And that gets us within a whisker of a minute for that project, which is about where I parked it. That's about all I could stand. So here's a summary of the optimization so far. Stock Django, the per class test fixture is the big win. Fixture bundling knocks another quarter off of that. And then database reuse takes that last little 10-second annoyance off. If that saves 4 minutes per test run, like in this, when you have a team of 4 and they run their test suite maybe 4 times a day conservatively, you save about an hour a day. That comes out to 261 hours or 32 working days per year, so I figure every team member can take an extra week off. And if you do happen to be using Django and have a lot of fixture-heavy tests, you get all this pretty cheaply by using Django Knows. So let's talk about user interface. Even though we are technical people, we still have feelings, and they can still be hurt by inconsiderate software. And I cannot help but rant a little bit about what we put ourselves through with the dots. So this is the standard Django test display. It basically is what standard unit text test runner spits out. I took the liberty of trimming out some of the time-consuming setups, so this actually is not real time. Now, I can see I got an error there, right? But I can't see what the heck went wrong. So I've just got to sit here and wait until the very end when hopefully all the tracebacks will show up all at once. GG, what? Yeah, I could invoke strace and try to guess what's going on now. So I find that pretty inconsiderate. In fact, I don't even know how long I'm going to have to wait to see my results. Like, should I get a sandwich, or should I get, a spouse, or... In fact, this goes on for over 2 minutes, so we'll just sit and we'll wait while this goes. No, just kidding. I might not just be just kidding, because when I was trying this earlier, I actually couldn't get it to skip to the end. Yeah, it's doing that again. So, yeah. So everybody knows what the output finally looks like. You end up with these wrapped lines full of garbage that say, equal signs, yay, or traceback, most recent line last, as if you've never read a traceback before. And then unless you're using like some kind of fancy IDE or something, you've got to ferret that number out and figure out what crazy line wrapped file it was and get into your editor, and it's a pain in the neck, and computers should be good at doing this for us. What a waste of time. So wouldn't it be nice instead if we had something like this? This is an alternative test runner that I put together. It works with your existing tests. You don't have to do anything. It's got a little progress bar, fires up down to the lower right. You can always see what test is running over to the left. You can see the tracebacks as they happen. And there are no wasted lines. The tracebacks are even formatted interestingly, and they're actually more useful than they look. They're pretty, but they're also very useful. So we omit the useless lines, the equal signs, the most recent line last, that kind of stuff. But also we omit test frames that aren't interesting. So test frames that are out of the guts of unit test or are part of a comparator like noses EQ underscore or assert equals. Those things get stripped off. In fact, the first frame of every traceback is guaranteed to be the one out of your test. Let's see, try to compress it horizontally. All the path names are optionally relativized. The function names are colored, so you can just scan down through the stack and see what's going on, figure out where you are. And then you can actually copy and paste these bold test names at your prompt to rerun them. So you say manage test and then paste that thing, and you can rerun a failed test very easily like that. But my favorite part of all is these editor shortcuts, I call them, these gray things that happen to start, in my case, with BBEdit. Here's how they work. So once you know where you want to go, you just triple click on one of these editor shortcuts, copy, paste real quick, and you pop up right in your editor at the line that indicates. Works in Emacs, works in VI, works in TextMate, works in BBEdit, works in anything that takes the little plus command line syntax for indicating a line to edit on. Nose Progressive is on PyPy. You can grab it right now. Just pip install Nose Progressive, and then pass with Progressive when you do your tests. I like to mash all that into an alias so I don't have to type it all the time. Great. Well, thank you so much.